Let's quickly look then at what type of graph they gave to the learners in last year's paper. Let's go. So I say there are also graphs in chemistry, and the graph that they gave last year in one of the questions was this one. Read it carefully. The volume of oxygen gas produced is measured every 10 seconds. So this is our independent variable. The time marches on. We allow time to move. The results obtained, which was the volume of oxygen gas, which was measured in cubic centimeters. So you could see there was nothing at the beginning, and then after about 10 seconds we had about 18 centimeter cube, and so forth and so forth. So the question is, what do the examiners normally want you to understand here? Number one, that you need to know that this curve, which is not a straight line, you can take the gradient at various points. Yes, we can find the gradient of a graph at a particular point. There are various words for it, like instantaneous gradient, etc., and we normally take the y over x. In other words, in this case, it would be that value from there to there over the x value from there to there, and we can plot the gradient there. Now look at that slope of that gradient and watch it furthermore. Notice how that slope is a positive slope. In other words, something was coming out of it, getting more. But as we go on, we notice that the slope is decreasing, it's becoming flat after a while. So there we have the last slope, and that one is 0. Notice again a steep slope. That slope is decreasing until it becomes, in other words, there the volume of gas produced was 0 by just looking at the slope. And how do you find this? You simply take a point there and you put the y18 over 10, which would be 1,8, etc. And so you can measure the point there, which is y over x. I take that triangle, and from there y over x, if you will. There you go. But here we got no y and no x, so that answer there is a 0 gradient. Please note, the examiner can ask you at any point to determine the y value over the x value, that way around. Good. So it's y value, which you read over there, and x value, which you read down here at any point. Where's the y value here? Across there. X value down there. At any particular point can you do it. But I think what's important, let me just summarize this one for you. We then say we find the gradient, which is also called the tangent to the curve. We find in this case it is decreasing until it reaches 0, and the units is always y units over x units. Gradient is always y over x. So it's centimeter cube over divided by the seconds. We call it per second. That's how we write it. Make sure that you can at least do this. But if the examiner is given that kind of graph last year, we can't expect him to give the same graph this year. You know, question papers are different every year, but they test the same concepts of gradient in chemistry, especially in the rates of reaction. And here you saw that the oxygen gas was liberated, and what they did was, in that one I saw they used peroxide and some copper oxide. So that's what they did. They used some peroxide, and here I bought some peroxide from the chemist, which is hydrogen peroxide, and they wanted it to decompose, and they simply added a catalyst there quickly, which in this case I think was copper oxide, if I remember correctly. What does my bottle say? Yes, copper oxide, that's correct. And they just added the two together, and they shook it up, I suppose, and heated it a little bit, and then oxygen came off there. And this is exactly what the hydrogen peroxide looked like, and that is what the copper oxide would look like. Yes, I see some bubble, and you can smell how it's decomposing, breaking down actually. That's right. So what is a different type of graph that the examiner can possibly show you? Because we must be ready, if you want to get 100% in the chemistry paper, and it's possible. Many learners got 100% in the physics and chemistry papers, and I know some of you say, wow, is that possible? Yes, it is. If you know your work and you work hard, we've got about 3 months to go. But let me quickly get to the next graph and show you that you must always be prepared for any eventuality. Here's another graph, which came, I think, in 2010 March exam or 2009. And what would happen here now is the question. First question, look at here. I know the independent variable is temperature here. In other words, I change the temperature. I can see how I change the temperature. 20 odd, 20, yes, 28, and then I change it to over 30, almost 34, 35. There you can see I change the temperature. That's the independent variable. But what does this mean? 1 over time, what is that called again? And it's measured in per second, 1 over a second. What does that part of my graph represent? This was the question. What is represented on the vertical axis? What do we call this? 1 over time? We call it the rates. The rates of the reaction while I increase the temperature. Now you can see that the rate was increasing. That's clear. Now let me show you how we determine the rate or the gradient. There's a gradient at the beginning, flat, 0, nothing is happening. As I increase the temperature, look there, my gradient is steadily increasing. Look at that, increasing, going, the slope is getting higher and higher. And if I go to the last one, there I can see my slope. So the question is, what conclusion can be drawn from the results? If I look at this, what conclusion can I draw? I take my slope, which is indication of the rate of reaction, rate of reaction, rate of reaction. As I increase the temperature, what is it? Of course, my reaction rate was increasing. That should be my answer to that question. So I've shown you a graph in that curve, and I show you one in this shape. What other shape is there possibly that we could be expecting? You should never ever be caught to sleep. You must always be wide awake. So go through all your past question papers and find all shapes of graphs, particularly these kinds that examiners will ask there, because this is a practical part in your syllabus. You must do rates of reactions practically, otherwise you haven't done any chemistry as yet. Here's another possible type of graph which I say that some learners must look out for. This one here, look, this time is coming down. This, if I draw a slope there, a slope there, decreasing, and if I have a slope there until 0. So something was going down slower, the volume of something. I need to find out what it is exactly. And of course my independent variable again is the time. So what have I said this before I sum up for you on my screen? You are definitely going to get graphs, and I will bet my bottom dollar it will probably be more than 3 graphs. That's what I think. You should at least get 2 in the physics paper, or be able to draw 1 or 2 in the physics paper, and you should at least get 1 of them in your chemistry paper, if not 2. You must be ever ready to do the gradient on the chemistry side, determine out the gradient. That means you take the y value and divide it by the x value and use the same units, y units, over the x units, x-axis units. Make sure you can do that. And when it comes to the physics one, you must know what's the independent variables, the dependent variables, and or the constants as well. Remember, your gradient is always a constant. That's a good hint to remember. Provided it's a straight line, then it is always a constant. Now let's summarize and see what we have and what you should remember. So in case you have missed out on anything, let me remind you that when you get a graph on this axis, which is called the x-axis, you must remember that that represents any value there is the one that you manipulate, that you choose, like time for instance, or that is under your control. That quantity is called the independent variable, and we always find it on the x-axis, no matter whether it is in chemistry and or in the physics paper. Next one, what do we call that axis there in chemistry? In maths we would call it the y-axis, but in physics we call it the dependent variable, as these values are dependent on what I do on this axis. I think in maths they have a term called the fx, f of x, and then this is x. In other words, this one is a function of this one. This value here depends on the value that I get there, but I use my graph as a guideline where to go to. So I am there, then I take the graph and I move over, and then I go down. If I'm here on my dependent variable, this number, I go to the graph, depends on that x value there. If I'm here in my measurement during the experiment, I go across to the graph, straight line, and I go down and see my independent variable, the one that I manipulated. And that's how I find x and y values, and that's how I find my coordinate pairs as well. So that value there, straight to the graph, down there, gives my second pair of the coordinates. And you know how to write that now. What's important is that if this is a straight line, then I normally call it the gradient, but the gradient and at a curve, for instance, is one that touches only at one point. Then more importantly, I would say, is that you must be prepared for any other graph that comes your way. What would you say? If this was a chemistry graph, where would I find the independent variable? Of course, it would run along this way. Where would I find my dependent variable, the quantity that I measured during the experiment? Like you saw in my one, the amount of gas released then would be along this one. And again, if I want to have the, say I want to have at this point, I would want to find out what is the reaction rate here. Then I take a gradient or a point, and a gradient I get by going to the y value, and from there I go to the x value. That way around I will get my reaction rate. So please practice such a one, drawing in your gradients and working out. Now what if they give you such a graph? What happened here, you think? It was an increase of something. Yes, that was a decrease of something during experiment. This was an increase until it stops increasing or be given out. And these graphs are very, very important. But I would like to say two things before I actually end off. The first is that it is important that you actually read up in experiments and you encourage your teacher to do it, or go to a place where you can actually see the experiments. And we find that at some schools they actually have DVDs where you can look up these experiments. Many of the publishers also give out experiments, and you have done some experiments during the year. So you should have a hands-on approach to physical science, not only the physics, but also in the chemistry part of it. And you must remember, as I said, the examiner can test you on your understanding of anything that you are supposed to have done practically in the examination, up to a maximum mark of 40% of your paper. Are you listening? 40% of the paper. Now, where are you going to find exactly what is it that you have had to have done practically? Of course, in your physical science examination guidelines. If you go in there, you will notice that the examiners will tell you all the time. If you read through your lines, if you read through your guide, you will see where they explain when you should be doing practicals. For instance, look at this one. You can't see it properly, but I can read for you. The production of chlorine from the chloralkali industry, and above that they say, describe the following electrolytic processes: the decomposition of chloride of copper chloride, which means that this is a prescribed experiment that must be done in your class. Now, if I were you, I'd check with my teacher and find out from the examination guidelines in 2009 what exactly are the ones that are prescribed that I must know, that I should have done, that they can ask me in the form of a graph. I need to know that. Because then only when you know for sure and can you be thoroughly prepared and can you get a very good mark in physical sciences. Remember that physical sciences are based in the natural world of ours. In other words, we bring the world into the classroom. So I must be able to do practicals. Where do I find it once again? In my examination guidelines, and my teacher will have a list of those things that I must know, and I should be able to draw graphs, or I can be tested on with graphs. Lastly, I encourage you to do your best. I was speaking to you 2 or 3 times more before October month, and that you will actually get into your work. This is the time of the year that you must pull out all the stops, that you've got to put aside everything else that you have to do and focus on the very important work, because the matric certificate unlocks the door to the next 60 or 70 or 80 years of your life. If you don't have that and your basis is weak, or your base is weak, your foundation is weak, you're going to be struggling for the rest of your life. But if you get a good mark now and you get a good start with many A's on the certificate of yours, then you will unlock many doors. Then you can go study further. Then you'll get out of the cycle of poverty as far as possible. So my encouragement to you is work hard. As you'll see on my last screen, I'll put it to you. I say that you have to keep well, but work hard. And from the Western Cape government and all the other provincial governments, keep well. And then we'll see you next time when we talk more physics and chemistry.